Finding limits algebraically and numerically given a function. Okay, so the only time we can do this algebraically is when the function, as you see, factors, or possibly we could evaluate the function directly without having to do anything. So the idea also is that the number that we're given as x approaches this particular number, -1, will result in a divide by 0 situation. But when we factor it, we see that the numerator and denominator have the same factor, which cancels, and then we no longer have a divide by 0 when we plug in a -1. So we factor it, cancel the factor, plug in a -1, evaluate it, -4. Let's look at Excel for that first example there. So our x value is approaching 1, and I set this up horizontally so that we can approach from the left and the right, the same way that we did graphically. And you can see my x values. It doesn't matter where you start, but you're getting really, really close to that particular x value. So I've got -1 point, whole bunch of zeros and a 1 on the left, and on the right, negative point, whole bunch of 9s. There's the function typed in. See all the things, the multiply, the caret for the exponent, the parentheses, top and bottom. Got to get all that stuff, and then just I copied and pasted it all the way down. The cell references take care of everything. So on the left, as we're approaching -1, you can see that number gets closer to -4, and on the right, it gets closer to -4. Even though we can't evaluate it, the limit is still -4. Example 2, same idea, factor it, cancel the common factor in top and bottom, and then evaluate the function. Here is it in Excel. We're going to +1 this time. So you see my x values on the left and right getting closer to +1. The function typed in, there it is, getting closer to 7 on both sides. Again, we can't evaluate it at 1. It divides by 0, but we can take the limit. Example 3, this is a piecewise function. So we evaluate the piece on the left, which is where it approaches from the left, less than 1. We evaluate the piece on the right, where it approaches from the right side, greater than 1. Those are not the same values, therefore the limit does not exist. Here it is in Excel. From the left, approaching 1, from the right, approaching 1. The formulas, because it's a piecewise function, are not the same. So be careful when you copy and paste. Those are different formulas. Example 4. This one is just evaluate numerically, since there is, we can evaluate it algebraically. If you look at the denominator, you can see you can factor out an x, and then the x minus 2 will cancel out. But you're still going to have a divide by 0 situation, whether you cancel that factor or not. So you can't really do this algebraically. We have to do a table of values. So on the left, we're approaching 0. On the right, we're approaching 0. We've only got one formula. Same formula there. So on the left, you can see that negative number gets larger. And on the right, that positive number gets larger. So you can see my notation. On the left side, it's going to -infinity. The right side is +infinity. Those are not the same, so the limit does not exist.